G'day guys, this is part 2 of making yourself a high-powered pinpointer. So what we have to do is we need some material, non-conductive and very much a very low dielectric. And when I say a low dielectric, I mean like air. Materials at a low dielectric is cotton, things like Teflon, polypropylene, polyethylene, anything of that nature is a fairly low dielectric. But the thing is, as well, you want as much air in the structure as you can get. So what I'm using this stuff. It's just packing material. You can see for it, you know, it's if you order small parts through AliExpress, usually they come wrapped up in this stuff. It's like a very thin foamed polyethylene or something of that nature. It's nothing fantastic. It's nothing special, but that is what we want. Something of that nature. It could be thicker, it could be thinner. We really just want a couple of millimeters. Doesn't matter if it's you know, an 1/8 of an inch, you know, 2 millimeters, 3 millimeters, 4 millimeters, 5 millimeters. The only thing is, the greater the thickness, the more it's going to come out on your pinpointer, the internal parts of it, and then you've got to get it to fit in a tube. So you might, instead of using 15 millimeter plumber's pipe, you know, the plastic white plumber's pipe, you might have to use 20 mil or 25, doesn't really matter. But if you want a nice slimline one at 15 mil, this is the way to do it. Get something like this. Now, you know, we've already wound this thing here. There's our two ends. One snapped off because I was wiggling it around. But as I say, just go into the previous video. This doesn't need to be neat as long as we've got our required inductance, around about 300 microhenries. And this was PVC wire, 7 strands of 0.2 millimeters, tin plated. Remember, tin plated. If you use silver plated, it will not work. All right, you need the tin. Tin is slightly resistive, and as each strand rests on the next strand, they all touch together, it's all slightly resistive and burns up the eddy currents that would try and form on a big, you know, a larger structure. As soon as you get, God, noise going on out there. As soon as you get too many strands, too thick, and you start using very conductive materials, you'll generate cross-sectional eddy currents, and they'll die off when the receiver turns on, and it'll desensitize everything. So you must use, you can actually make out of Litz wire if you want, but that's going a little bit overboard. I actually have made them out of Litz wire. It makes no damn difference, but you've got to use thin Litz wire. And if you want to make it out of Litz wire, right, oops, over here, this is 0.05 by 120 strands. And there's 50 meters on that. You could make it out of that. Your resistance would probably get down to about 1/2 ohm, maybe even less. So that could be an issue. If you do get down to ridiculous low ohmage, trying to, you know, when you get 300 microhenries, what you can do is get a metal film resistor, and you really want to make sure it's at least, for this, what would it be? You want 1/2 watt, and just put a 0.05 or something like that surface mount resistor in series with one of the wires. Doesn't make any difference which one, preferably not the one you use on your grounding for the shield, on the other one, and that would help a little bit. You're not going to get as much field as such, but you probably won't notice a difference. Okay, so you could make it out of Litz wire, but that's a waste of good Litz wire. Just use El Cheapo wire, it works fine. Okay, so we've got this stuff, right? What we want to do, I'll do this bit first. It's just magical, it's the right length, more or less anyway. So you could probably wrap this once, twice. Doesn't make much difference. We'll just see how we go. I haven't done this with this material before, but I haven't even done a test run. We'll see what happens anyway. We'll go around. Maybe if you had some tack glue, you could probably tack it down, but we'll see what happens. It's probably a bit thick for my liking, but yeah, it's not very tight. It's not very tight because it wants to move around a bit. I'll tell you what I can do. I'll be clever here. I'll get my hot melt glue gun. I'll stick that on 100 watts and it'll heat up very quickly. But what we'll do in the meantime, we need to look at the shielding. How are we going to shield this? And there's a lot of tricks to shielding, right? This is the stuff I use. Hope that's the right way around. I've got the camera facing directly down, so I hope it's not flipped. This stuff here, Y Shield, HSF54. There is a 34 as well. I can't remember which one's the low resistance one and which one's the high resistance. I'm pretty sure this is a low resistance one. The other stuff might be for about 1,000 ohms per inch, and this stuff is lower. I think it should work out. That's a noise maker. It's going to come in here and start doing noise. So anyway, what we want to do, I've got 3 materials here, okay? Better show you what they are first. This one here, it's something like you would wrap, well, I've seen people wrap the outside of their coils with this to protect it. They use it on, people technically call it, what? Hockey stick tape, or bicycle grip tape. Wrap your handlebars on your bicycle, at the top of your hockey stick to give you a bit of grip. It's actually a cloth. It's meant to be sticky. It never is. I mean, it's not sticky. Well, I think what happens, it sits around for a long time and they just sell it off cheap. This came from China. This came from Alibaba. It's dirt cheap and it's called Certoplast, which is CERTOPLAST. That's all it's got on it. So it wasn't expensive. Might have been $2 a roll. And I got a heap of rolls of this stuff. So what I've done here, I've got, that Certoplast. Masking tape, just El Cheapo masking tape. Nothing special. You know, $1.50 a roll, whatever it is. It's probably more now because of inflation. Everyone's jacking up the prices, even if they don't need to be, because they jack it up as much as the consumer will bear. I'll tell you that. There's no cost in making that stuff. Okay, we've got that, and I've actually done a direct paint on the spacing material on this polyethylene. I've never done it before. We're going to find out. So what we are aiming for, and I hope my meter reads right that way. I hope you can actually see it because I can't bend my head down far enough to look. But anyway, got the meter on. I've got it on 2K range. Let's try. We'll try the masking tape and see how it goes. Okay, 30, 40 ohms. That's not too bad. And we'll stick it on 200 ohm range. Oh, there we go. Normally on a coil, you'd find the shielding to be around about 80 ohms per inch. That's a little bit low. Doesn't make much difference, believe me. For this sort of thing, it won't make much difference because we're going to have an open structure. This stuff here, the tape, I put it on What's happened? I think what happens, this stuff, as it dries out, it drops in ohmage. The way it works. And I think because this is cloth, it's actually keeping it a bit wet. I'll stick my finger in there. Yeah, it's a bit wet still. So it's probably still drying, but we'll try it anyway. See what it says. No, you can see that 300 wiggling around. It's drying out. It's slowly drying out. So we're not going to get a consistent reading until it's dried out. We'll see what happened with this foam stuff. Painting it direct. I don't know. We'll see. Oh, it works. There you go. So what's that? We'll go in the low range. I'm reading it upside down, so I can't see the digits. I mean the dot between the digits. There you go. 34, 35, something or other. That's good enough too. You can actually paint the Y-shield material. Now I've got stuff on the probes, but we can actually paint it directly on, but I want to hold it tight, so I'm going to tape it. So, okay, hopefully the glue gun's hot enough. And so it is. I'll just drop the power down. With one of these glue guns, you get this, it's got a 60 and 100 watt rating. And it's got a green light for 100 watts and a red light for 60. Don't you think it should be the other way around? And what they actually do, right, as far as I know of this, these are made they'll work on either 110 volts or 240. And I think what actually it does is that it may actually have a shunt on the element. So you hit 60 watts and it runs at half voltage. You put on 100 watts, it goes at 240 or something. So I don't know how it can be universal for 110 volts, like in the US, and then 240 volts for Australia and other countries that use 240 volts, standard. So don't leave it on 100 watts, it'll probably burn out. So I do it to get it up to speed and then flick it to 60 and leave it there. So what I'm going to do, I'm going to put a bead. I'm going to put a bead along here, just small, tack it, just a tacky bead. Nothing fantastic, like that. And I'll probably go down here. Get rid of that. You can spill over there somewhere. I'll turn that. Ouch! Got me on the finger, the rotten stuff. So yeah, told you, bloody hot. So hopefully I got that on the edge, and don't want to pick up too much of the paper because the paper will rip. Okay, that's good enough. Let's see if we can wrap it a bit tighter and see how it goes. This, like I say, this stuff's just an offcut. Something like that would be ample. I don't really want to have a big, thick thing. I don't think capacitance is much of an issue on this to the shield, so we just chop it. And get that there. I'll just, I could have just put masking tape around this and done it, but I was going to tack this on. Hopefully I don't stick my fingers in it like last time. Do that and just push it. Come on, stick. Murphy's Law. Because there's no conductivity, thermal conductivity in this stuff, so it's going to take a while to tack down. If you get it too hot, it'll melt this stuff as well. So it's not critical, something like that. And you probably want to fold the ends over, but we'll see how we go. It's probably far enough away from anything. The active end, you want to have that shielded, because you're poking it near stuff, it will interact. So that's where we are at the moment. But because I got such a good job on the masking tape, I think it might be an idea just to keep everything stable. You know, if this moves around, it might crack the paint. So what we'll do, we'll just use masking tape on it. It doesn't matter where we start and how it goes, as long as it goes on. Yeah, even though I got that on fairly tight, it still wants to move around, so just overlap it as you go, because if we're going to paint it, we don't want any open parts. This will be quite good actually, even though it's it comes up very, very low. Oops, there's me saying overlap it and I didn't. And because we use one continuous piece of this, it will be conductive all the way up. Make sure I'm overlapping. Sorry if the video works a bit wonky or something, but it is what it is. Okay, we get here, we probably want to squash that around a bit there, and I might tape it first. It might be a bit better behaved. Now we don't want too much spacing on the end, because if you want to poke towards very small targets, you don't want to have, dear me, hang on, I'm going to have to put a couple of little bits on here, I think. Now I need 3 hands. Okay. This is probably the bit where it gets messy. We'll see how we go. Pull it tight. Yep, someone's in trouble. I know the microphone on this will pick up that. There we go. How to make yourself famous. Okay, something like that. As long as we can get the paint around, under. And we're going to have to shield around here as well, but we'll do that with the cable on there. It's no big deal. It really isn't a big deal. So what I do, I get this conductive paint. Never ever work it from the big bottle, because if you knock it and it falls over, you are gonna scream, because it's just about impossible to get out. You would need, because it's water-based, you'd have to flood the room to get rid of it. It's really super dense stuff. So what I would do, normally, you know, get it. I'm just using a cotton bud because I can't find my brush, but something like that, just paint it on. So that'll be fine. It'd be quicker with a little brush, but yeah, I think what happened, I had a brush here and I forgot to wash it and turned into a solid lump. So always wash your brushes. Like I say, you could probably come up with a better way of doing this. You know, if you wanted to do it more professionally, but this is just to get the job done. This will work beautifully though. I mean, I wouldn't do this and sell it commercially. Even though it would work, you could hide it in a piece of plastic tubing. But, you know, someone will pull it apart and then point it out to everyone and, yeah, make a big deal out of it. So anyway, this is the way it goes. Because it's an open structure, we don't care if we short it out all the way around. It doesn't need a an overlap gap. If you want to do other types of coils, you should use an overlap gap in the coil. People don't, but I do. My coils always work better than everyone else's. I don't know why. Yeah, now I get black fingers. I'm getting to the business end. Okay, maybe I'll grab it by the wires and try and do it like this. Like I say, if you want to, see the thing is with this shielding stuff, right? For what it is, you don't want a great whopping bottle. It's damn expensive, right? I mean, I've had that, they say stuff goes off, it doesn't, right? They say, oh, use it after 2 years. God, that's 12 years old, that stuff. No, it's more than that. It could be even 14 years old. And just as long as the lid's on tight, it works fine. But I'm getting black fingers, damn it. Don't stick your fingers in PowerPoints. Oh, dear me. Yeah, make sure you just do the end there, because that is going to be reactive if you poke it near anything wet, sand, water, salt water. But we're going to put it in a tube. We're going to make it waterproof, so that's that. Okay. There you go. That's that bit done. Now, if you want to make your own black shielding material, you can do it. Now, I'll try to remember, there's a special ingredient you use. What you can do is you get an old carbon battery, right? And you can grind up the anode, the carbon rod anode, and that will work. You can also use the carbon in the, what do they call it? Ammonic paste or something. I think that's what it was. I'm going back 40 years and trying to remember what it was called. Yeah, it's got carbon in it as well, graphite, and it's probably maybe alkaline, so you probably might need to neutralize it. There'd be a way of doing it. You could probably, get all that paste to wash it in some type of, I don't know, a weak acid, like even vinegar probably, just white vinegar, neutralize it, clean it up, wash it. I don't know how you really wash it, but I suppose then you have to evaporate the water out of it. And you can use a binder and use it as a paint. And I'll try to remember what you got to mix with it. There's something that, oh God, it's on the tip of my tongue. I haven't used it for years and years and years. But, what's the stuff called? It's totally escaped me. But there's a chemical, you get it in and it comes in flakes. It looks like, God, I don't know what it looks like. It's sort of an off-white color and it's like waxy flakes. And damn it, I'd have to go and try and hunt it up. It's probably out in the garage or something. But you mix that with the carbon, or you can use carbon black, but you mix this stuff with it and it makes it more conductive. Oh God, I can't think of the name of it. Really, it's just escaped me. But also what you do is you mix that into a water-based primer and really load it in, and then you've got a good paintable conductive paint. I will find it, what it is, and yeah, work it out. Yeah, there you go, black finger. And like I say, it probably could be the rest of the week like that now. But this stuff, yeah, it does stick quite well. Now, what do we got? This is a little bit wet, looks a bit dry there, about there. Be pretty conductive. Well, 116 ohms, beautiful, no problem with that. Over an inch, measure it over an inch. Because this stuff's got graphite in it, you touch it with metal objects, it looks like it comes off. It doesn't. It's like, if you get, or anything with graphite in it, and you touch it like that, and it goes silver, it doesn't change the conductivity. It's just drying out, so it'll be going down a bit. As long as we get somewhere between 30 and 80 or 100, 200 ohms even. I've actually seen commercial coils where they're trying to get the detector to operate as fast as possible, and the shielding material is up around 400 ohms, and it doesn't seem to interact with the ground Well, otherwise they wouldn't be able to sell it because they're gold detectors. So, yeah, I want to get that off my finger. So anyway, we got to this part. Now, what we have to do is we have to say here what wire is we're going to designate as our return, our negative. And we have to connect the negative to the shield and leave the positive well alone, right? We don't want to put any, just don't touch the one you're going to use to the center of the coaxial cable, or that it is a coaxial cable even though it's a Litz wire cable. Yeah, but you just don't want to have that touch anything except the center part of the cable. This can touch the braid, and also the braid, the outside part of the cable goes onto this. So there's tricks of the trade in doing that as well. And to shield this, we can put a tube on it, or we can wrap it with more of this down the wires and then cover the braid and shield. And where is my cable? It's over here, hanging off a detector. For the time being, come here, you. Everything's jammed up here. I'll just turn that hot melt glue iron off. Okay. That's where the wire broke off, as you can see, because I was wiggling it around too much. Also, that's probably a little bit close there, but I don't think it's going to matter. If you weren't watching what you're doing, you may short it out here. But normally I'd have that a little bit further out, strip back a little bit further. Not important, really. I mean, not. It's not going to stop it working. It's just a, you know, a thing you'd do if you wanted it to work really, really well, and you know, not have any problems. Now, a trick of the trade, if you want to stick this on here, you probably want to get it relatively as close as possible. But when you want to do the, have I got some of that? I was going to show you something, but I'm trying to spot what I was going to show you. You can't use just anything to join it. Like I've seen people use all sorts of copper tapes and that. You don't want to do that either. You don't want to use anything like even braiding like that. That will send off eddy currents like crazy because it's copper and it's conductive. On each strand is conductive to each other. It'll look like a target. If you get thin wire, tin plated wire, and put it over your coil, it won't sound off. You put that over your coil, it'll sound off, right? So we don't want that sounding off problem. Now, here somewhere, I have a different type of wire. Actually, I'll just grab, I've got some really nice silicon wire there. I don't want to do it with the silicon wire because, oh damn it, I'll use the silicon wire. Well, actually, here's some silicon wire. But anyway, this stuff here, this, you can see this is multi-stranded like crazy. This is a lot of strands on this, right? A hell of a lot of strands. And it's tin plated. And what we'll do, I can probably get away with using this actually. We'll leave a little bit of insulation in the middle to keep it all in one piece. But this stuff's usually very easy to strip, unless it makes a liar out of me. There we go. So if we leave it like that, we can use one end to go around the wire, and the other end, we can just put a bit of paint on it. You don't need to, just put a bit of masking tape around it and just press it on. You could paint it if you wanted to. It'd probably make it better a little bit. So what I'll do, how about we do that? We'll just paint it on. Okay, this makes a good connection, and you'll probably never ever have any problems ever again. So do that. And I don't really want to stay there with my fingers on it for an hour, so I'll try and jam something under that. And yeah, just like that, it will make sure I've got it in frame. Yes, just make sure that it will set like that. You could, after you do all this painting, when it's all dry, you could put more masking tape on it just to hold it all nice and stable. You know, this stuff here, you know, it's a little bit flexy, but when you put it in a tube, if you got this, cut this into long strips and wrap it around about here, make another one here and make one down the bottom, and just put enough on there so when you slide this into the plastic tube, it's sort of snug, it can't rattle around, it won't move. And also on the end, if you've got one of those domed end caps, you want to push this all the way down as far as you can. You don't want too much spacing. Now, those domed end caps are probably about 3 millimeters thick of plastic at the far end, and that's going to cause a little bit of loss of depth on really tiny stuff. So, you know, you're already, you know, got the shielding here and a bit of foam over it. You could trim it off and just put the tape around the end and then paint the top of the ferrite rod across and join it all up. You know, that would save you 1 millimeter. And on the end cap, if you wanted to, you could probably, if you had something like a flat drill, I don't mean like a milling piece, is more what I'm talking about. And if you actually are very careful and measured it all out with a drill press, you know, put the drill press down onto the stop and just see that it stops like 1 millimeter away. You put your end cap in and then you bring down the mill piece and just mill away 2 millimeters of plastic at the diameter of what this is. So you get closer to the end. I mean, depends. If you're looking for fly specs, yes, do it. If you want a big target, high power pinpointer, which that's what this project is, for big gold or a target that's in a hole that you can't get your coil in to work out whereabouts it is, this will do the job. Especially if it's, you know, a good distance away still. You know, if you've got something this big, you know, God wish, that the little pinpointer, even though it's that big, and you've got it, you know, 6 inches in the side of the hole, a little pinpointer may not get that little handheld one, but that'll get it easy. So you know where to dig. You don't keep digging in the wrong spot. As I mentioned in the last video about people who continue digging down and down and down, and then they widen a hole and the target falls out the sidewall, and they could have saved themselves half an hour of digging, or more, or less, depending what the material is they're digging into. Anyway, this thing here is drying. Maybe I cut this one here. This is the part 2 video. And then when it's all dry, I'll do the part 3. But you got the gist of it anyway. All you need is some conductive stuff, carbon, graphite. Big thing too. Hey guys, I've seen people do this, and I just like it. You know, you got to realize they go and buy nickel spray, right? Don't buy nickel spray. Nickel spray is ferrous, right? You might as well coat it in iron. It won't work. It'll just kill it. It'll lose its inductance. It'll lose everything. It will not work. It'll go deaf as a post. And, you know, you might as well tie a rock to it. It just won't do anything. So nickel spray is out. Any type of ferrous material spray is out. Don't use it. You can get, I'm pretty sure you can get graphite sprays, but I don't know how conductive they are. And they're expensive for what they are as well. You really want to get something like this. I'll tell you what, I know who sells it. You can get small quantities of shielding material they use for guitar stuff. You know, in a guitar where the knobs are and all that sort of stuff, they paint the inside of the wood with this stuff here, because otherwise the guitars are a mega ohm impedance, and all it'll do is pick up heaps and heaps of noise. You've got to be shielded, otherwise it'll just sit there and hum with mains hum. And you can get that from guitar shops. It's, you know, the technical name for it is Aquadag. They used to use it on the back of cathode ray tubes in old TV sets, right? And old TV, anyone who worked on TV sets back in the day always had these little bottles of Aquadag, because sometimes it would chip off and you'd paint it back on. And it works the same as this. Obviously, we don't have a lot of cathode ray tube oscilloscopes or TVs or anything much anymore, and maybe it's a little bit out of favour, but guitar shops, and I know I think Marshall in the US have it. I don't know the other guitar shops that have it. I have seen it sold by Marshall, actually. So the other guitar shops around, maybe your local ones will have it. And it's tiny little bottles, and it's not expensive, because you don't want, like, even if what I've got in there, it's hardly anything. You could probably make about 25 or 30 of these things, just like this, because it goes a long way. And it, even though it's a little bit, still relatively expensive. This Y Shield stuff is expensive. A half litre was probably, I don't know. I'm going back 14 years with inflation, I don't know. I think it was $120 back then. So you don't want to buy it. Get it from the guitar shops. It's the same stuff. It works fine. If it's too low in conductivity, like it's 1 ohm or something like that, you shouldn't do this. But you can get an eyedropper and drop 1 drop of water into it, right? Because they're all water-based. But if you go overboard with the water, and it's like a thin edge of the wedge, if you go too much water, it'll just lose all its conductivity. It will be useless. So you can do that. 1 drop of water, mix it in really well, let it dry, test it, see where it sits. Don't go putting too much water in this stuff. On this, you can do it, right? I know you can do it because I've done it. On the directions of it, it says do not add water. But by adding water, it changes the resistance when it dries. But be careful, because I think once you go too far, it loses its interparticle bonding. There's that chemical, I can't remember the name of it. I know it will probably wreck the particle bonds. It'll get too much spacing, it won't be conductive. It'll be the, fall off a cliff in conductivity type thing. So you've got to be careful. So this is drying out rather nicely. I'm going to tape that just so it stays on. You can, if you want to, get thin wire, like just the wire, thin wire, and being tin plated, you can wrap it around, because those strands will do nothing, right? They'll do absolutely nothing. You don't want to, wind it so it's like on itself. Wind it up in a little bit of a spiral, then tape it. It just gives you more surface area to tape down on. Yeah, we'll just let that set. And yeah, I'll prepare things for part 3. And that should do that. Catches.